Hello students and welcome to IP Study Lecture videos. In this video, we are going to cover the 5th chapter of grade 8 mathematics and the name of the chapter is Algebraic Expressions. Students, first of all let us see what are the different topics we are going to cover under this chapter. So we'll see what is an algebraic expression, then we'll see how to add them, how to subtract them, and in the latter part of the video we'll see how to multiply two algebraic expressions. Okay, now students, first of all let us understand what is an algebraic expression means. So student, till now we have already understood how to add numbers or how to perform any operation on numbers from addition to division. Yes, so we are using operations on numbers only till now. Now if we have an expression of mathematics or a phrase of mathematics where we use letters as well as numbers with a mathematical operation sign like 2 plus x. Here a number is added to a letter x and this phrase or expression is called algebraic expression. Student, a single number is also an algebraic expression. A single letter is also a algebraic expression. So student, we need to understand that any phrase in mathematics where there are numbers or letters or both combined with the help of mathematical operations like plus, minus, multiply or divide, then that phrase is called algebraic expression. It can be in any form like this. Yes, so these are algebraic expressions. Now, what is terms of an algebraic expression? Student, in an algebraic expression, if an expression, there will be multiple expression combined together with the help of plus and minus, like 2x minus 3y. Here there are two individual algebraic expression 2x and 3y which are making a single expression like this, and these two are called the terms of the whole algebraic expression. So a term is separated by plus or minus sign. Clear? Now moving to the next topic, addition of algebraic expressions. Student, before proceeding to the method of adding two algebraic expressions, we need to understand which two algebraic expressions can be added or what terms can be added together. So student, first of all we need to understand what is a like term. So student, like terms mean two expressions having same variables as well as same exponent on the variables. Like let's suppose I write 2x square, then we have minus 3xy square, and the third one is 3x y, and the last and fourth one is 4x square. Now student, we can see over here that these two terms or these two expressions as of now are same in terms of having the variable and the exponent on the variable. So these two are called like terms. Let us see one more example. 2xy square minus 3 by 2 y square x. Here also the variables, the letters are called variables because their values can be changed. Yes. Now student, here we can see there are two terms or two expressions. These are two different expressions. We will not call them term. Now here the variables are same x and y, and the exponent also. Here on y it is 2 and on x it is 1. So both have same exponents on the variables, and variables are also same x and y. So these two are like terms, and the terms which are not like are called unlike terms. So we can add only like terms. Yes, and unlike terms cannot be added. They are just written as it is. Yes. So here one question is add 5x square plus 3x minus 8, 4x plus 7 minus 2x square, 6 minus 5x plus 4x square. Now to add them, we will use addition sign like this, then an addition sign over here. Now let us see what are the different like terms that we have. So we have 5x square and 2x square, and the third is 4x square together. Then for the term x, the numbers having x as a variable is 3x, 4x and minus 5x. So they will be combined. Yes. And for the constant, a number without any variable is a constant. Yes. So if let's suppose if we have 2x, then 2 is a coefficient of x, not a constant. But if only 3 is written over here, then 3 is a constant. So we will add constant without variable together like this, and we'll take the variable part as a common, and we'll add the coefficients of their coefficients, and at the last we'll get this as a result. So like terms for different algebraic expression, we combine the like terms and we find the final result. Yes. So there are two methods, one is horizontal method and one is column method. In column method, we write the expressions one over the other like this, aligning the like terms together. Sometimes the like terms can be at different position, so we have to arrange them such that they can be taken together like this. Yes. Now in horizontal method that we have already understood, we add like terms by combining those together, and in column method we just align like term first of all, then we'll add them one by one separately. Yes. Now subtraction of algebraic expressions are similar to addition of algebraic expression, where like terms can be subtracted and unlike terms cannot be subtracted. So it is a similar process that we follow, just there is one single change, that instead of adding we subtract, and while doing so we change the sign of the second algebraic expression that will be subtracted from the first. Yes. Now here let's suppose if we have subtract 4x minus y plus 6z from 12x minus 5y plus 8z, we'll write the expression, second expression first, and then we'll subtract like this. Now we'll change the sign inside the expressions that is written after the first will be changed with their signs, and it will be negative 4x plus y and minus 6z. Now we'll combine the like terms that we were doing in addition. So here we'll have 8x minus 4y and 2z. So it is quite similar process that we have followed in addition of algebraic expression, and column method is quite similar, just we change the sign of the terms of the second expression. Okay. Now students, moving to multiplication of algebraic expression. So multiplication of algebraic expression is quite complex than adding and subtracting. Here the rule that only like terms can be added or subtracted doesn't work, though it is used in the simplification of the final answer, but it at the initial stage any expression can be multiplied with other expression. It doesn't matter either they are like or not. Okay. Now how do we multiply algebraic expression? So it depends on the type of algebraic expression we are taking. So algebraic expressions are of different type depending upon the number of terms. So if there is one term, it is called monomial. If there is two terms, it is called binomial, and if it is three terms, then it is called trinomial, quadrinomial, and so on. And algebraic expression with more than one term is called as multinomial together. Yes. So multinomial can be a binomial, multinomial can be a trinomial, and so on. Students, this concept of polynomial, that is monomial, binomial, trinomial, is applied when the exponents on the variable of algebraic expression is a whole number like this. If it is negative, or if the exponent on the variable is a fraction, then this concept of classifying them on the basis of terms is not valid. So there is one rule before classifying the algebraic expression, which is a special case, which is called a polynomial, when it follows a rule that the exponents on the variable must be a whole number. Yes, students. Now, how to multiply two monomials? It means algebraic expression with only single term where the variables have exponent as a whole number. Now, to multiply two monomials, we multiply their coefficients. Let's suppose if we have to multiply 7x, y and 3x, then we'll multiply the coefficients. 7 times 3 is 21, and then we multiply the variables. So x, y into x. So we can use the law of exponent where x raised to the power of 1 multiplied with x raised to the power of 1 will give us x raised to the power of 2. So there are 2x, so I'll write x raised to the power of 2 and y as a single unit. So this is the final product that we have got after multiplying two monomials. Students, moving forward, there is a rule to multiply two monomials that I have already told you, that multiply the coefficient part first and then in the right side we multiply the variable part. Yes. Now moving to the next subtopic of multiplication of algebraic expression, multiplying three or more monomials. So it follows the quite similar process. Just we need to multiply the two first and the result will be multiplied with the third. Like this, we have a monomial 3 over 7 x raised to the power of 2 y raised to the power of 3 minus 14 over 9 x raised to the power of 4 y z raised to the power of 4 and 2x. So to multiply these two, we write like this: the first two will be multiplied together and the product of these two will be multiplied to the third algebraic expression over here. Yes, so now we multiply the coefficient like this and we'll get this as a final result, and then we'll multiply 2x to the final result that we have, and at the last we'll get this as an answer. And how to multiply? Just let's suppose if we have x cube y times x square y cube, then we write the variable one time and then we use the law of exponent where if the same base is there and the powers can be added in case of multiplication. So 3 plus 2 and y is 1 plus 3. So x raised to the power of 5 and y raised to the power of 4 will be the variable part of the final product. So this is the method of multiplying algebraic expression having variables, and it can be applied to monomials or two monomials or three monomials depending upon what the question asks. Now moving to the next topic, multiplication of a monomial by a polynomial. So a monomial can be multiplied by any type of algebraic expression, either it is binomial or trinomial or more than that like quadrinomial. So in that case we use the method of distributive property of multiplication over addition and subtraction depending upon the terms, the sign of the terms. So let's suppose if we have a monomial A and there is a binomial B and C, it will be B plus C, which is a binomial. So we need to just multiply one by one to the values or expression inside the bracket. Let's suppose if we have 12x and we have to multiply it by 4x plus 9, then in that case 12x will be multiplied with 4x first, 12x will be multiplied with 4x first, and then 12x will be multiplied with 9. So it will be 48x square, and here it will be 108x. Together the expression will be 48x square plus 108x. So instead of multiplying them in one go, we multiply one by one and then we just simplify the last expression that we got. Now here we have a similar example that you can go through. Now multiplying a monomial by a trinomial. So it was an example of multiplying a monomial by binomial. A similar method can be applied to multiply a monomial by a trinomial, where instead of multiplying the two terms, we multiply by the three terms that the trinomial will have. Yes, like this. So to multiply 4x and 2x plus y plus z together, what we can do is we can write like this first, and then we can multiply 4x with 2x, then we can multiply 4x with y, then we can multiply 4x with z. So we'll have 8x square plus 4xy plus 4xz. So it is quite similar process of multiplying a monomial with binomial, which is applied to multiplying a monomial by a trinomial. So if the number of terms increases, you can use the same process, just the number of steps or the number of terms will increase. Yes, multiplication of two polynomials. How to multiply two polynomials? Till now we are just observing how to multiply a monomial with monomial or monomial with a polynomial, but here we'll see how to multiply two polynomials. It means the number of terms in both multiplier and multiplicand, that is a and b, will be more than 1. So first is multiplication of two binomial. So let's suppose if we have a binomial as a plus b, another is c plus d. So in order to multiply these two binomial, we'll multiply a with c plus d and then b with c plus d, and then we'll simplify the two values that we got. Here we have an example to multiply 8x plus 2y square and 6x minus 4y. So 8x will be multiplied with 6x minus 4y separately, and then plus 2y square will be multiplied with 6x minus 4y separately, and the result that we'll get individually will be added together, and the last expression will be getting after simplifying all the like terms. Yes student, there is another way of multiplying each term of one binomial with each term of another binomial and arranging this product so that like terms are combined column wise. This method is called column method of multiplication of two binomials, which is illustrated over here. So instead of multiplying horizontally, we multiply them in column method. So this is the method that you can go through, multiplying 3b first with all, then writing like this, and then multiplying 2a with the two terms that we have and got the value like this, and then we can add like terms and the last expression will look like this. Yes student, you can research about FOIL method that we use in multiplying two binomials and just explore the method, which is quite similar to what we have learned over here. Yes, now let's see one of the example of multiplying a binomial by trinomial. So here we have find the product of a square plus 2b with a square minus 2ab plus 2b square. Here the multiplicand is this and multiplier is this. So if we write a square plus 2b and we multiply it with a square minus 2ab plus 2b square, first of all, we'll multiply a square with this expression. So a square times a square minus 2ab plus 2b square. So let us first of all find this value. So it will be a raised to the power of 4 minus 2a cube b, and it will be 2a square b square. So this is the first expression that we have got. Now multiplying 2b. So 2b times a square minus 2ab plus 2b square. So 2b will make it 2a square b minus 2ab square, and here we'll have 4b cube. Now we'll combine these two, and there is no like terms over here, so the whole expression will look like this. The first till this and the second till this. So this is quite easy to multiply a binomial or a polynomial with other polynomial if we break into step by step process, where each term of the multiplier is multiplied to the expression in the multiplicand, and then whole expression is then simplified on the basis of like terms. So students, this is all from this chapter. I hope you have understood the concept of adding, subtracting, multiplying algebraic expression. We'll meet in the next video. Till then, keep practicing, keep learning.